So when you look at this picture of the Earth, if you showed it to my grandfather, first of all, he would think that you made it up, because you couldn't possibly get such a picture unless you had a spaceship. The other thing is he wouldn't believe it because he'd say there's too many clouds. The atmosphere doesn't look like that, because he would have brought up with a world view or a global view of a globe, and having clouds on the map of the world globe. And by the way, this is from the Japanese Aerospace Exploration Agency, JAXA. So let me assure you, it is in high def. You can do this, you know, like professors, see that JAXA logo right there? And then they go like this. So, ladies and gentlemen, this is not only April 12th, 2011. This is Yuri's night, people. Yuri's night is a big deal. I see we go forward, Bill. No, can't. This is an area. Well, this is this thing is been causing...
Science rules!
Yeah, it's science. Okay, 3, 2, 1. It's Yuri's night.
Woo!
Normal people out here, I'm sorry, but Yuri Gagarin flew around the Earth once on April 12, 1961. He came back into the Earth's atmosphere. Things weren't going so well, so he jumped out of the space capsule and opened his parachute. Of course, what's so hard about that? But he did, and he landed okay. And the people were like totally freaked because it meant that humans could orbit the Earth. Now, because these images to you are routine, and because it's also believable, I like to think of you all as being members of what I like to call the space generation. That's interesting. Let's try it this way. So you know what you have to do to be a member of the space generation? You have to be born after October 4th, 1957. Yes, there were people alive. You might not believe it, that's when Sputnik first orbited the Earth. The first human-made satellite went around the Earth and sent back these fabulous beeping signals that people heard for several years. And it was quite an accomplishment. The thing wasn't small. It's 30 kilos. It was probably more massive than this lectern. And people realized that you can build a rocket and put things in orbit. That, if you will, physics is true and rocket science is true, and changed the world completely. And you guys are all part of that because you were born after all this took place. So just 2 weeks ago, oh wow, it's pretty dark. The Messenger spacecraft, which is another fabulous acronym, but it's named after the Greek god, or the Roman god of the Messenger. Greek guy was Hermes, same guy. But this spacecraft went to Mercury, and we have now the coolest pictures of Mercury anyone's ever had, learning more about the interior of the solar system and stuff. But here's the thing that's different. This picture, all of these pictures of these planets, were taken, if you will, with the spacecraft back to the sun. The spacecraft is looking out away from the sun. And I hope this gives you pause for thought. The Earth is right here. The whole Earth is that dot. And we are here. All of us. That's everybody who ever lived. Every Georgia peach. Every sea jewel. Every baseball player. Every oak tree. Every bacterium. Everything existed, took his or her whole life on that little dot. And that, I hope, is sobering. So naturally, when you look at a picture like this, you say, well, what about Mars? Right, exactly. Thank you for not blurting it out. So Mars is another dot, and I would like to take you all to Mars briefly. This is Mars. Well, actually, this is a picture of Mars. If I have Mars here, I mean, So this picture came back, I was alive for this, in 1976. Kind of, if you will, the height of the disco era. The whole town had given way to disco, and really the important work of new wave artists like Sid Vicious and the Sex Pistols, that had not come to the fore yet. So this was taken on the 4th of July, 1976. Big deal. And everybody's very excited about this. And I hope when you look at this picture, you can get a sense that if you were to go to Mars, Mars is a place. And you can walk around. You'd have to be dressed properly. No, it's like a camping trip. You have to take, food and water. I mean, what's food? Tang. Take Tang. It's also very important when you go there to take something to breathe, because they don't have anything, if there are any of them, they don't have anything for us to breathe. But this picture is notorious or infamous or famous or well known because it was circulated around the world. New York Times, Papua New Guinea Gazette, what have you. And people realized that there's kind of a problem with it. They looked at these edges of the shadows, and they say, I paraphrase, but the scientist said roughly, huh? What? Yeah, that's blue. Yeah, it's blue. What? What's the big deal? Well, I don't think the sky on Mars is blue. What do you mean? It's a planet. I know, but it's a different planet. So it turns out the sky on Mars is not blue. And so they realized that they had electronically made the sky blue just reflexively, just by their expectations of what the Earth is like. And the great apocryphal thing is, they were looking at the U.S., the flag star field right there. That was the real thing that they noticed. The air on Mars, the sky on Mars is more like this color. What is that color? That color is orange or something, or taupe, or ecru, or eggshell. If you go to Nordstrom, where they sell women's stockings, upper right. I don't wear women's stockings. I am a huge fan. So the importance of the color of the sky on this other world affects us all because we're trying to learn about our place in space, our place in the universe, and it's very important to know about the geology of the Earth. Geo means the Earth, and the geology of Mars. And is there anybody here who's a geologist? Yeah, it's a couple of you. So what happens, you'll recognize these people. They all walk around like this. And then, a rock. You go to their house, their dorm room, their apartment, it's just rocks. Dude, what's with the rock? Well, this one's different. But I'm very sympathetic. Well, they are different because every rock tells a story, or at least my dad said. And my dad was quite the rock hound. Right? He was an amateur geologist. He called himself an Ed boy scientist. He's got a rock hammer.
Rock hammer for hammering rocks.
Some rocks. This is an Photogman being who's collecting rocks because there's some fabulous stratigraphy from some Silurian fossils, okay, and it's all great. So my father, unlike many of us, spent 4 years in prison camp in World War II. 44 months. And near as I was not there, near as I could tell, that kind of sucked. Not your first choice. They were captured from, I joke, they were captured from Wake Island, which is this little place in the middle of the Pacific Island, Pacific Ocean, nowhere. But it's big enough to build an airfield, an airstrip. So that's what my dad was doing for the Navy, and they were constellations, 4 dozen constellations, no problem. Most people don't know any. And then the story goes, the family myth is that my father reckoned time by constructing sundials everywhere they moved, everywhere the prisoners were taken. My dad would put a shovel in the envelope or whatever and construct a sundial. Is this true? I don't know. He came back to the States. He took a lot of pictures of sundials. He was given a lifetime membership in the North American Sundial Society. Are there accounting majors here? Yeah, you know, you've seen the accounting parties. You know how crazy that is. Wait till you see the sundial. They all stand around. So, anyway, among my father's great ideas was to turn the Washington Monument into a giant sundial. He wrote a paper about this and got published. You know, it's quite an idea. For some reason, they have not done that yet. But it would be cool. You'd have these rocks out. Oh, sure. You'd have these rocks out here, so-called plinths. Big stones, you know, a plinth, that's a great place to grab it. There's only 1 hour. That's what this rock you put a statue on, is a plinth. So then at the base of the Washington Monument, if you look closely, you'll have to take my word for it in this light, but right there at the concrete circle, the base of the Washington Monument, is the shadow of the monument. If you look closely, it is ever so slightly light blue. And I was forced to make up this word, cirrulescence, which would be a tinge of blue. There's a real word, viridescence, that's a tinge of green, but this is ever so slightly light blue. So you could ask yourself, Bill, in my case, why is the shadow blue? Why isn't it just jet black, the way a shadow would be the next time you're on the moon, just black? Because there's no sky. The Earth's sky fills in the back of the shadow with a little bit of blue and gives it what I love to call the cirrulescence. Well, then, I grew up with all the sundial stuff, right? Then I was asked to speak at Cornell University, which some of us have snow, like right now, probably. I got invited to this meeting, and they had this picture. The meeting was about Mars. It was about the Mars rovers, which we now call Spirit and Opportunities. Before they had names, they were Mars Exploration Rovers. And they had this thing there. That thing. And you see it's a lot better than the other ones. So I was trying to be cool, but after a few minutes, what is that? Oh, Bill, that's your photometric calibration target. That's photometric calibration. So, the idea is you point the camera at this shadow, and then you look at the color of the shadow, and that will help you figure out the color of the Martian sky. If you look at this picture in the shadow, you'll see it's just a little bit yellow because it was made in a room with room lights, and they're a little bit yellow. So I was also forced again to make up another word. Yellow shadow is xanthidescence, which is Greek for yellow. Xantho, we love the xantho. And so this idea is something that most of us have never thought about. You go through your whole life, you can tell the difference between outdoor light and room light. You're aware of it, but you can't put your finger. Yes, I know, there's some artists here, some photography people, yes, you know. But most people go through their whole lives without ever stopping to take note of this. It's quite a thing, as I mentioned, because how many other things are right under our noses that we never stop to notice? But anyway, I was in this meeting. They had this thing, and it has a metal stick about that high. It's about this big, taking it to Mars. Now, I am an aerospace engineer. thing that flies in the sector. I just wanted to reassure you, I was very well supervised. It's still flying. My too. It's still flying. One of the reasons it took me a while to convince my boss and everybody that this was worth doing is it added weight to the airplane. That's evil. You're never supposed to add weight to the airplane. So, but the Lord taking away the pressures, rest. Well, my boss again eventually. Well, this thing, I thought at first was adding weight to the spacecraft. I mean, can't you find a shadow somewhere? But then, my heritage, my father with his upbringing and all this stuff, I went, hey, you guys! We gotta make this into a sundial! And they're looking at me, Bill, this is the space program. We don't use sundials. Crying out loud. Bill, you have a watch on. We have Bill, what are you talking about? No, it'll be cool! Wrecking time on another world. It'll be like speaking Klingon. It'll be real. Instead, So Steve Squires, the head guy, thought about it for a few days and went, okay. So, my friends, right now there are 2 Mars dials on Mars.
Awesome.
This is a picture from Husband Hill. Rick Husband was a guy killed in the Columbia Space Shuttle wreck. And if you look down there in the lower right, there is our Mars dial. Very happy. And it casts shadows, and there are tens of thousands of pictures of these things because they are used to calibrate the cameras every time on Mars. So here's a close-up. Now understand that at NASA, nothing is out of focus. That would be a mistake. At NASA, we say this is defocused. Because it's too close, or it's close to the camera lenses. And so, but that's okay. That's all we're looking at is the color of the shadow. And if you look at it there, at that shadow, going back to the Nordstrom rack or what have you, you will see what I call orangey-escent, which is a tinge of orange. Another word that Bill was forced to make up. Now, when you have a sundial, if my father were here, he would tell you, sundials should have a motto. They should give you something to think about. And you'll see sundials that say, well, they don't say, you have to read it. I only count the sunny hours. Or you'll see, life is but a shadow. There's one in France, Woodruff Sullivan, who worked on this thing. One in France. This is existentialism and Camus, the stranger and life sucks and then you die. It says, le tout blessant, la demer tu. So every hour wounds you. Every hour wounds you. The last one kills. It's a sunny day. We're all going to death. We're all wounded. That's great. But on Mars, our 2 Mars dials have a motto, and it says 2 worlds, 1 sun. That's right here. 2 worlds, 1 sun. Now that's kind of cool, people. It means that the shadows on Mars are created by light from the same life-giving star as shadows on Earth. And I hope that gives you something to think about. I hope that helps you ponder your place in space. Now, I want to reassure you, taxpayers and voters, I did do a little work on this thing. I did a little analysis of the gnomon. That's the thing that sticks up on a sundial. Oh, by the way, see, what I brought to the party is when you're near the equator of a round planet, like the Earth or Mars, don't want a triangle for your gnomon, the thing that sticks up. You want a symmetrical object. Like if you go to Hawaii or someplace, you'll see, in the tropics, you'll see a rectangle sticking up, and sometimes, quite often, just a post, a stick, what's traditionally called a noon pole in English. And so anyway, I did the analysis on the gnomon to make sure it wouldn't vibrate loose, bang around and smash all the electronics and sabotage the whole mission. And the thing, I mean, it's indestructible. You can tow a truck with it. By the time it got to be wide enough to cast a shadow, wide enough to get enough pixels in shadow, it's like indestructible. But let me reassure you, somebody did send me this picture.
Oh.
And I realized it was April Fool's Day. Crazy kids, you kids with your Photoshop. All right, whoever did it, I want to know you sucked in. So, let's say that this picture of the sun represents the sun. Then this picture of the earth will represent the earth. Very good. Now the earth is one astronomical unit, 1 AU from the sun. And this is a unit humans made up. It's the average distance, agreed upon average distance from the earth to the sun. 150 million kilometers, 93 million miles, something like that. All right, and you can't forget it because you go, AU, Earth. So if we go out here to Mars, Mars is 2.5 times as far away, 2.5 AU. And then Mercury is 40%, 0.4 AU. And Venus, 3/4, 0.7 AU. All right. You would expect, I hope, when you're 2.5 times farther from the sun, the place will be colder. And indeed, Mars is cold. It's so cold.
How cold is it?
It's so cold.
How cold is it?
Bill is a nickname. It's so cold that they have dry ice. It's not water, it's a little water ice, but it's frozen carbon dioxide on Mars, the ice cap. Then Mercury is really hot. It's 350 Celsius, something like that. Very hot, way above boiling, and it's much closer to the sun. But the surprising thing, I hope surprising to you, Venus is much, much hotter than Mercury, even though it's quite a bit farther away from the sun, almost twice as far away. Much, much hotter. And this is because of the Venusian atmosphere. So we say Mars is too cold, Mercury is too hot, Venus is way too hot, and the Earth is just right. This is the Goldilocks planet on which we live. So if we go back to Mars, there's the Topekaru eggshell, and this is another picture from Viking, and these data are from a later mission, the Sojourner rover. Anyway, the atmospheric pressure on Mars is 7 millibars. The atmospheric pressure on the Earth is just about 1,000 millibars. 1013 is the old standard. Now, millibar is no longer a system international, because it has a factor of 100,000. It has a 10 to the 5th in it. So the real unit, or the preferred unit rather now, is hectopascal. What? Really? Millibar, that's cool. Hectopascal. So my proposal is your generation will change it to hex. You have all lived through that number changing. 0.03% is the same as 300 parts per million. You were all alive when it crossed from 349 parts per million to now almost 390 parts per million. So rounding to one digit, that number is now 0.04%, 400 parts per million. And this tiny change, in what seems like a very small, almost insignificant part of the atmosphere, is changing the world. And that is why I want you guys to take over and change the world. Back. This is a picture of Venus taken by a Russian spacecraft, Deter 14. Now, the spacecraft only lasted a little over a half hour because Venus is crazy hot. Crazy hot. Venus has 90 times the atmospheric pressure of the Earth. It would be 90,000 times. It's so hot.
How hot is it?
Venus. And if you showed up with lead. Okay, now wait, there's more. Okay? There are clouds made of sulfuric acid. And it rains sulfuric acid. But wait, the sulfuric acid doesn't get to the ground because the surface is so hot that it evaporates before it gets there. By Western traditional descriptions, Venus is like hell. I hope you all have played this game, where like the floor is like lava. The Venusians, if there are any of them. Oh, by the way, Venusian is a 20th century adjective. In the 19th century, anything having to do with or characterizing Venus was venereal. That shows you got a chance. So, the temperature of Venus is crazy hot. And the reason is the Venusian atmosphere has a lot of carbon dioxide, and it's very high pressure, and it holds in the heat by means of the famous greenhouse effect. The light comes through, heat comes through the atmosphere, hits the surface, is re-radiated with a longer wavelength, more infrared, more lower red, and it just stays there, hot, hot, hot. Now, here in the audience, there might be a few people who don't believe in climate change on Earth. And if you are among those people, I strongly encourage you to do what I did. Go to the Ice Core Lab in Glendale, Colorado. Not Glendale, California. That is a whole nother. It's like a valley, totally different. Colorado. The Ice Core Lab is 36 below Celsius. That's almost 40 below Fahrenheit. It's cold. Crazy cold. You have to put on all these clothes. The mittens like the kid, like when you're a little kid, they bundle you up and outside. Yeah, so I asked Todd Hinckley, Dr. Hinckley, the guy who runs the place, why did you choose minus 36 Celsius? Is that to maintain the eutectic point of certain isotopes? No, but we did not pick it. I took the thermostat and turned it all the way down. As low as it'll go. In this building, where it's crazy cold, they have these aluminum foily tubes full of cylinders of ice, pieces of ice about this big, 10 meters long, 30-something feet long, that they drilled out of the Antarctic ice sheet, or the Greenland ice sheet, or the Kamchatka Peninsula in Siberia. And an ice sheet, by the way, if you're scoring on this, is a little different from a glacier. An ice sheet is where the ice is sliding on ice. So it's ice on top of ice. It's a super ice. And you take one of these things and you go into the warm room, where it's 7 below. Oh, you take off your, oh, this is great. You take off your scarf. So the snow falls on top of the previous year's snow, crushes it down, the weight of it crushes it down, and the tines of the snowflakes break and trap bubbles of gas of the primordial, of the ancient atmosphere rather, and these sand particles that you see in that close-up are that's from Greenland, but the sand particles are from China, from the Gobi, the desert in China. Anyway, what gets trapped in there are tiny bubbles of ancient atmosphere,